Hello and welcome back. In this section, we are going to talk about how do we build a model. If you have been following this series, you now know the basics of what makes a model. You know about tokens, you know about language models and how vast amounts of data is used. We touched upon machine learning. We looked at how AI engineering is different from machine learning. We talked about model development. Then we talked about application development. So you can get all these basics. If you missed the previous episodes, just go back and look through the playlist. In this episode, we are going to look at how do we build a model. So artificial intelligence may appear very magical from the outside. Still at its core, it's the result of meticulous engineering, massive data curation, and a sequence of design choices that defined what can and what cannot be done by the model. So in this section, we step behind the curtain and look at how an AI model is built. At its very core, it's all about data. The foundation is data. The story of every AI model begins with vast amounts of data. Data kind of defines what the model knows, how it reasons, and even what cultural or linguistic biases it inherits. Most language models are trained on open internet data collected from sources such as Common Crawl. Common Crawl is a public data set that periodically scrapes the web. And then we have Google's C4 dataset, which refines Common Crawl by removing spam and some of the boilerplate text. So despite these efforts, the quality of data remains quite uneven. There is misinformation, repetition, bias, they're all part of it. But that's what we have. Models like GPT-3 and Gemini were built on these massive, a little imperfect datasets. Yet, through the sheer volume of information, they learned to capture the underlying patterns of human language, and they did that remarkably well. It's also worth noting that the internet is not linguistically balanced. What do we mean? English dominates most of online content, which naturally makes English-centric models perform best. This imbalance has inspired the creation of language-specific or multilingual models that better represent underrepresented languages such as Hindi, Mandarin, Arabic, so on. In an effort to make AI more inclusive and equitable, that is the approach we had to take. However, when the task is specialized, such as predicting protein structures or aiding drug discovery, general internet text is insufficient. Such models require curated, domain specific data sets. Structured information drawn from scientific papers, medical literature, all of those things, they really help us build a domain specific data set. The more focused the task, the more important curation becomes. So that is data. Without data, the model really is nothing. Now let's look at the two stages of training a model based on this data. Training an AI model involves teaching it to recognize patterns and make predictions. We talked about ML pipelines, data pipelines, all of which are part of training. So training occurs in two main stages, pre-training and post-training. So pre-training is the process by which the model learns the general structure of the language. It digests vast amounts of text and starts forming connections, such as which word often occurs together, how sentences are structured, what is the meaning of these flow. This is where the model's raw intelligence is born. Then we have post-training. On the other hand, it's about refinement and alignment. It shapes the model's behavior so it better matches human preferences. Using methods like reinforcement learning and human feedback, the model learns which responses feel more natural, safe, and helpful. So, if pre training is the method of teaching the model how to speak, post training teaches it what to say and when to say. So, we had data, we talked about training using pre and post training. So, the model still needs something more, which is sampling. What is that? Choosing what to say. So once a model is trained, it doesn't simply know the correct answer. Instead, it calculates probabilities, predicting what token, word, or subword should come next based on the context. So this is where sampling comes in. Sampling determines how the model selects from its many possible next tokens. A greedy sample might always pick the most likely word, resulting in predictable mechanical text. A temperature or a top K sample introduces a little bit of variability, allowing creativity and diversity in responses. So, in essence, sampling is how AI learns to strike a balance between consistency and imagination, a choice between sounding correct and sounding alive. Because humans are that. They are not always correct, but they are alive. It's not that they're completely wrong, but yeah, they make some choices. So the next part is designing the brain, the model architecture. After data, the next major decision is architecture, how the model is structured internally. A small 7 billion parameter model may fit on a single high-end GPU and respond quickly, making it easier to deploy. In contrast, a massive 175 billion parameters model like GPT-3 would require large-scale infrastructure and consume enormous computing power. But all of this can capture far more subtle relationships in the data. Today, nearly all the state of the art models share one dominant design, the transformer architecture, which is something we will touch upon in the next section. It requires its own episode. So, meanwhile, think through this. We will look at the core of models. We will talk about transformer architectures in the next episode. Meanwhile, enjoy learning.